Good afternoon, everyone. Today we're going to find the mean and the standard deviation for this data set with 5 data points. The mean is just the average, and the standard deviation is, of course, a measure of how spread out the data is from that mean. Okay. So first of all, I like to define first our average, which we denote by x with a bar on top, x bar, as the sum of the individual data points. Call that the sum of the individual xi's, where this is x1, x2, x3, x4, x5, right? The first data point, the second data point, third data point, so on and so forth. So we have something to call them when we're doing our calculations, and we know we have to divide that sum. This sigma symbol means the sum of, so we read this as the sum of the individual xi's, meaning the sum of all the data points in our data set, right? And we know that to get the average of a data set, we sum up the data points and we divide by the number of data points, right? And so in this case, x bar is going to be the sum of our 5 data points, i.e. 10 plus 12 plus 8 plus 11 plus 17, and we know we have 5 data points, and so our n value would of course be 5, and so the sum goes in the numerator, 5 in the denominator, and so our mean is 22, 30, 41, 58, 58 divided by 5, and so our mean is 11.6. Okay. Now, for the second part, our standard deviation, again, that is a measure of how spread out the data is from the mean, right? Are the data points all compact, nice and tidy around the mean, or are they fairly spread out? That's kind of a measure of the standard deviation. So, we denote our standard deviation by this sigma symbol, a little circle with a tail at the top, and this is the square root of, again, this sigma symbol comes into play again, which reads as the sum of, and we want to take the sum of the difference between the individual data points, the xi's, again, the xi's means the individual data points, right, where x1 is the first data point, x2 is the second data point, so on and so forth, right, where xi is the ith data point, so this can apply to any number of data points, xi minus the average, so we want to look at the difference between every data point and the average that we've computed, and we want to square those differences, okay? Now, we square these differences because if we don't square them, the negative differences and the positive differences could possibly cancel each other out. And then it would be kind of weird to consider this to be a measure of how spread out the data is, because if it's really spread out, the positive and the negative differences might just cancel each other out, which wouldn't really be what we're looking for. But when we square a value, we know that squaring any value, be it positive or negative, gives us a positive number in the end. And so that's why we bother to square these differences, okay? And so once we've squared the individual differences between each data point and the mean, we square those and then we take the sum of all of those squares, okay? Don't take the sum until you've squared each difference, okay? Get the difference, square them, and then add those all up, okay? And we finally divide this entire sum by, again, n, the number of data points in the set, and then we'll take the square root to finish it all off. So, for us, that means, first off, let's get, I'll use the blue marker again. Let's start off with the sum of the difference between each data point and the mean, and then squared. So that will be, our first data point is 10, our mean is 11.6, so we're going to do 10 minus 11.6 squared, right? And we're taking the sum of all of these, and so we're going to add them all up. So we can do that right away, plus, now we go to the second data point, x2. That's 12 minus our mean. Again, the mean is always the same, it's always 11.6. So that stays consistent, and we're summing them up, so we keep on adding. x3 is 8, and so we'll have 8 minus 11.6 all squared. I'll start a new line here. x4 is 11, 11 minus 11.6 all squared, right? And then finally we have our largest value of 17. 17 minus 11.6 all squared. And now we are ready to sum all of those values up, as these can catch. I will need a calculator for that. Feel free to do this on your own. We'll be back in 1 second. And that will give us that should give us a sum of 45.2. So again, the sum of means we add all of these values together, and this should give us a sum of 45.2. Now, this is not our standard deviation, right? This is only the sum of the differences squared, meaning the numerator inside this, this equation. And so to put it all together now, make sure you guys understand what I'm doing here. I'm just separating my solution into sections here. So that 45.2 is going to be our numerator. And so, almost ready to finish this all up. So we have our standard deviation is going to be the square root of the sum of the differences squared, 45.2, divided by n, 5 data points. And we take the square root of that, and so sigma, this symbol is lowercase sigma in the Greek alphabet. That's going to be the square root of 45.2 divided by 5. That is 9.04. And the square root of that should be very close to 3. Close enough that we can write it as 3.0. And that is our standard deviation. And that's how we do any standard deviation. It can be a tedious process by hand if we have a lot of data points. So hopefully the data sets that you're working with are not too large. Hope this helps. Thanks for watching. Take care.